Hello, I'm Nguyen, and I'm going to present our paper titled Towards Responsive Architecture that Mediates Place, Recommendation on how and when an autonomously moving robotic world should adapt a spatial layout. The possibility to adapt space is essential for our everyday usage of architecture, such as to vary lighting, ventilation, or privacy through outdoors, windows, or curtains. However, it is rarely to see these adaptations in the scale of spatial layouts. For example, sliding partitions to transform an open living space to a private working space. One of the reasons for this is the requirement for manual labor to move around these heavy elements. It is thus unclear how the adaptation of spatial layout would become practical in our everyday space. Meanwhile, looking at empirical findings of environmental psychology, especially in the office context, we can see that different spatial layouts can influence our social spatial behavior and social comfort. For example, the way that a visitor approaching an office worker is influenced by the layout of desks, partitions, and doorways. Whereas these effects were generated by static spatial layouts, it is unclear how the adaptation of spatial layouts can also activate such influence on social spatial behavior. In the SIGCHI subdiscipline of robotic furniture, it has been proven that robots can communicate intentions to nudge people behavior with their dynamic movement. For example, a seated chair that moves in repetitive patterns can recruit people in a public space to join a chess tournament. Whereas these nudging effects happen without specific consideration to the spatial surroundings, it is still unclear whether or how the adaptation of spatial layout can also communicate intentions within an architectural context. The research question of our study is therefore, how can spatial adaptation purposefully influence the holistic experience of occupants in an office breakout space? By spatial adaptation, we mean the robotic adaptation of spatial layout in an architectural way. By purposefully, we mean to be supportive, be considerate to occupants, such as to support their activity or their social spatial experience. And by holistic experience, we mean to take into account the whole architectural context, which is complexity. To make sure that the study captures the holistic experience, we base the methodology on the sense of place proposed by pioneers in architectural and urban design. Accordingly to very spatial quality, which is the physical manifestation of a place, we deploy 6 adapted layouts. To very situational qualities, which is the context of a place, we asked the participants to conduct 6 different office activities. And to very subjective qualities, which is the meaning of a place to the occupants, we included 3 participant cohorts: the office workers, the past visitors, and the newcomers. The study happened in a breakout room with postmodern interior style, a high ceiling, and bright natural lights. The robotic world was assembled on-site with the robotic hardware in an aluminum frame and PVC cover. The adapted layout were designed around 3 main architectural zones: a desk, a set of sofa, and an architectural model of the building. We adapted each zone into 2 different layouts with opposite spatial qualities. For example, Desk 1 covers the view to the terrace, while Desk 2 reveals it. Similarly, Desk 2 blocks the direct circulation from the hallway to the desk, while Desk 1 allows it. To test the robotic impact, the spatial adaptation randomly unfolded in 2 ways. For example, in reactive adaptation, the participant moved to a location to conduct an activity before the robotic were approached to adapt the zone that they chose. In proactive adaptation, the participant waited for the robotic world to finish adapting the zone before deciding whether they want to join it or not. The study involved 26 participants with 99 unique adaptations, 25 hours of video recordings, and 8 hours of interview. Using grounded theory to analyze the data, the study resulted in firstly 6 dimensions of how the participants experience spatial adaptation as static architectural manifestation. I will explain 2 dimensions. The first one is connectivity, which describes how spatial adaptation was perceived to change the circulation of passers-by. And the second one is uniformity, which describes how spatial adaptation was perceived to alter the consistency of the visible furniture. Specifically, connectivity can steer passers-by circulation away from the participants for more private activities such as reading or phoning. However, by covering the participants, it also makes the passers-by unaware of their presence. For example, here B1 was walking behind the robotic world, yet passers-by were talking loudly. Uniformity helped enhance the ergonomics as B8 enjoyed the working space with surrounding office appliance, or B2 said that she felt cozy being sheltered with a sofa and a painting. Data analysis also resulted in 5 different dimensions of how participants experience spatial adaptation as a dynamic act. I will explain 2 dimensions. The first one is reliability, which describes how the participants decided whether to draw a proactive adaptation based on their experience with previous adaptations. For example, B11 said that she believed the world was trying to make good spaces, so she tried to draw although it looked confined. Secondly, agency describes how participants perceived their own agency in controlling the behavior of spatial adaptation, such as to wait before sitting down to trigger an adaptation or to choose a specific zone to steer the adaptation to their preferences. We then propose 8 design recommendations for spatial adaptations. Firstly, there are 3 recommendations of how spatial adaptation should unfold, in that it should gain trust through its behavior by adapting appropriate places to build reliability before it can nudge occupants to draw its proactive adaptation. We also recommend of how and when a space should be adapted, in which the 3 qualities of place should complement each other towards a recognizable sense of place. When there is a significant unbalance between any of the 3 qualities of the sense of place, reactive adaptation should be triggered to balance it again. Meanwhile, proactive adaptation can unbalance the qualities of place deliberately if it's predicted that the occupants will change their behavior accordingly. Our study therefore contributes to human-building interaction by proposing the consideration of the architectural context. To robotics, we're introducing a novel way for robots to nudge behaviors, and to architectural design by introducing spatial adaptation as a design language with specific design guidelines. So thank you a lot for listening to my presentation. I hope you have a good time at the CSCW 2022 conference. I'm looking forward to meeting you, and I would be glad to answer any of your questions.